This Pat's Tutors, Scientia Ipsa Potentia.
Welcome to Success Tutors Chemistry Video Lecture Series. I am KOLA AKINTUNDE. Our topic today is isotopy. Isotopy. Isotopy is a phenomenon whereby atoms of an element, two or more different atoms of an element, have the same number of protons with different number of neutrons. They have the same number of protons with different number of neutrons, which gives rise to different mass number. In our last lecture, when we talk about particular nature of matter, I told us that to calculate mass number that we represent by letter A is going to be proton plus neutron. The number of proton plus the number of neutron will give us the mass number. If you have an element like this, we denote this with A, which is the mass number, and then Z, which is the atomic number. Atomic number is the same thing as proton number. So let's say, for example, you want to calculate the mass number of chlorine. If chlorine have number of neutron, if the number of neutron is 18, for example, and then the number of proton, which is equal to the number of electron, obviously that one is 17. So if you are calculating the mass number, which is A, you add this one together, 35. But there is another chlorine, we call this one chlorine 35. There is another chlorine that we call chlorine 37. That chlorine 37 have 20 neutrons, and then the number of protons there is still 17. Then when you add that together to give you mass number, that will be 37. So you can see this is chlorine 35, and this is chlorine 37. And we usually represent the mass number of sodium to be 35.5. We do a little bit of calculation there for us to arrive at 35.5. But in a nutshell, this chlorine 35 and then chlorine 37, we call them isotope of each other. So we said that an isotope is an atom. Isotopes are atoms of the same element that have the same atomic number, that is number of protons, but different mass number. And this is due to the difference in the number of neutrons that we have in that atom. So let's see some calculation example. Calculation of how to calculate the relative atomic mass of an atom. I said why we have something like when we have two atoms of chlorine, different one, one is chlorine 35, one is chlorine 37, and then we know that the relative atomic mass of chlorine is 35.5. In example 2, we talk about chlorine. So in this example 1, it's like in a sample containing 100 atoms of X, 70 were found to be X9, that is atomic mass of 9, while 30 were found to be X11 isotopes respectively. Determine the average relative atomic mass (RAM) of the atom. From the information provided, we were told that we have 70 atoms of X9 and we have 30 atoms of X11. So when we add the two together, 70 plus 30, that one will give us 100 atoms. As said earlier in the question, that we have 100 atoms present in that sample. So if you want to calculate the relative atomic mass, you calculate 70 over the total of X9 and 30 over the total of X11. So we have, that is 70 over 100 times 9. Use the relative the molar mass, the atomic mass that you have there, then you say plus 30 over 100 times 11, the mass number of the second atom. Then when you calculate this, 0 cancels 0, then you have 9 times 7, that's 63 over 10, plus, cancel this is then 33 over 10. And when you divide this, you are going to get 6.3. You divide this, you are going to get 3.3. Add it together, that will give you 9.6. So it means that the relative, therefore, the RAM of the atom in question will be 9.6. Now let's consider chlorine also in example 2. Example 2. Chlorine atoms contains 75% of chlorine 3517 and 25% of chlorine 3717. Calculate the relative atomic mass (RAM) of chlorine if the number of protons is 17. Sincerely, the relative atomic mass of an element that exhibits isotopy is the average mass of its various isotopes as occur naturally in the quantity of the element, as we have seen in the first example. So here we are going to find the average mass of these two isotopes also. So from the information provided, we have 75% of chlorine 3517 and 25% of chlorine 3717. So from here, as I have said earlier, that we are going to use the mass number in our calculation. We don't need the atomic number, we don't need the proton number, we don't need the number of electrons, it's only the mass number that we need them. So 75%, and this question is in percentage, unlike the first one that is talking about the number of atoms that are present in the sample of the element. So here we know that percentage we always add up to 100. So we are going to have 75 over 100 of times 35, which is the mass number of chlorine here, plus 25 over 100 of 37. So here, this will give us 26.25 plus, when we manipulate this, is going to give us 9.25. Adding up these two, we are going to get 35.5. That is how the RAM of chlorine add up to 35.5. Let's see another example. We are going to talk about silicon. We have silicon 27, 28, and 29. Let's see example 3. Yes, silicon 28, 29, and 30. Example 3. A silicon containing ore has 92% silicon 28, 5% silicon 29, and 3% silicon 30. Calculate the relative atomic mass of silicon. From the information provided, we have 92% of silicon 28 and we have 5% of silicon 29 and we also have 3% of silicon 30. So we are going to have 92 over 100, since the question is talking in terms of percentage. And in percentage, every figure will add up to 100 times 28 plus 5 over 100 times 29 plus 3 over 100 times 30. So when we manipulate this using calculator, we are going to have 25.76. The second one we add up to 1.45, while the third one we add up to 0.9. Addition of the three will give us 28.11. That is why the RAM of silicon is 28.11. Normally, the relative atomic mass of some elements are not in whole number because of the isotope that we have in different atoms of the element. So other elements, not all, some of the elements also, they exhibit isotopy. Like for example, carbon, we have carbon 12, carbon 13, carbon 14, which is the mass number of those carbon. We have carbon that have mass number 12, which is very common, mass number 13, and then mass number 14. Likewise, we have oxygen 16 and oxygen 17. We have hydrogen also. For hydrogen, we have normal hydrogen, that's the one that have mass number of 1. We have deuterium that have mass number of 2, and we have tritium that have mass number of 3. And before I conclude this class, let me briefly talk about isobar. We have isotope, we have isobar also. Isobar are atoms of different elements having the same mass number but different number of protons. Because of that, their mass number may be the same, but the atomic number are different. Example, if we have argon 38, 18, sorry, argon 36 rather, argon 36, 18, and then we can have sulfur 36, 16. You will see here that both of them have the same mass number but different number of protons. So here another example, we can have something like argon 40, 18, and calcium 40, 20. Even also we have potassium, an isotope of potassium, which is a potassium 40, 19. So here in isobar, you will see that if you are calculating, the number of protons here will be different, but their number of neutrons will be the same. Unlike in isotope, we have the same number, the same number of protons but different number of neutrons. But in isobar, we have the same number of neutrons but different number of protons. We are going to stop here, and in our next video we will be talking about how to calculate mass number, and then how to combine elements together to form compounds. Thank you.